Hey guys, so we're going to go over the magnitude and direction of a resultant vector. So you've probably seen a problem where they give you two magnitudes, which is just the length, and two angles. So I'm just going to make a note over each one of them. Magnitude, or the length of the vector, is represented by the double lines. So this is the magnitude of the first vector. This is the magnitude of the second vector. And the first angle given is the first direction angle for the first vector, and this is the direction angle for the second vector. So working with the first vector, we indicate vectors with the triangular brackets here. And to find the x value of the vector, you're going to take the first magnitude times the cosine of the first direction angle. Oops. And for the y value, you're going to take the first magnitude times the sine of the first direction angle. So I'm going to plug in the values, giving me 500 times cosine of 120 degrees and 500 times the sine of 120 degrees. And then from here, just solve. So usually if it's from the unit circle, I like the exact value because the more you take the decimal value and round it, the more you're diluting the answer in the end. So if it's not from the unit circle, just calculate it. Make sure your calculator is in degrees. But for this, use the unit circle in that case. 500 times the cosine of 120 degrees. Cosine of 120 degrees is -1/2. And then I'm taking 500 times the sine of 120 degrees. The sine of 120 degrees is the square root of 3/2. And then I'll simplify each one. 500 times the -1/2 gives me -250. And 500 over 2 would be 250, and I'm just going to bring over the square root of 3. So I'm going to try to keep it as exact as I can if the angles are from the unit circle. And then from here, I'm going to do the same with the second vector. So I'm going to take the second magnitude times the cosine of the second angle, which is 70, times the cosine of 45 degrees, and then 70 times the sine of 45 degrees. 45 degrees is from the unit circle, so again, I'm going to just write the exact value. So I'm going to write 70 times cosine of 45, which is the square root of 2/2, and 70 times the sine of 45 degrees, which is again square root of 2/2. So multiplying fractions, I go straight across. I'll get 70 square root of 2/2. I'll put that on top. And then I'm just going to divide 70 over 2 to give me 35, and I'll bring down the square root of 2. Same thing here, 35 square root of 2. So I've got my first vector and my second vector. Now I'm just going to put a little label with them, and you might see these as different variables, but since this is the x and y value of the first vector, I'm going to call this x1, y1. And since this is the x and y value of the second vector, I'm going to call this x2, y2. And from here, to find the resultant vector, which is between the two vectors itself, I'm going to add the two x values together. So I'm going to take -250 plus 35 square root of 2. And for the two y values, I'll add together 250 square root of 3 plus 35 square root of 2. So I can't keep on going with this exact value. I will be calculating it with the calculator now, getting the decimal value. And for the first one, I should get -200.5. And for the second one, taking 250 square root of 3 plus 35 square root of 2, I'll get 482.5. So this tells me that my resultant vector is in the second quadrant. Why? Because this is the x value for the resultant vector. I'm going to call this v sub x, and this is the y value for my resultant vector, v sub y. And this is at negative 200.5. Oops. So you just know the negative value, that negative x value is on the left. So that's why I'm just writing negative 200.5 over here. And then positive y, positive 482.5, is right here. So that means that my resultant vector is in the second quadrant. It's right here. And that's where the end of the vector will be. The initial part of the vector will always be at 0, 0. Now to find the magnitude of this resultant vector, which is just the length, you're just going to apply the distance formula. So the magnitude of this vector is just taking the square root of x squared plus y squared, which is negative 200.5 squared plus 482.5 squared. And make sure that you solve what's inside of the square root first before you square root that number. You should get 522.5. So that's the length of the vector from here to here. And to find the direction angle, so just remember, you have the x and you have the y. If you have the x and you have the y, that means you have the vertical and the adjacent. Notice that this is the height. If I were to make a triangle out of this, you have the height, which is 482.5, and you have the adjacent side, which is 200.5. Using SOHCAHTOA, tangent is opposite over adjacent, which is why the direction angle is always the inverse tan of y over x. So I'm just going to write this out on the side. So tangent of theta equals opposite over adjacent, or y over x. So let's say I just started there. So tangent of theta equals 482.5 over negative 200.5, y over x. This is not from the unit circle, so I'm not going to find the angle just by looking at the unit circle. So that means you manually have to get rid of tangent. The way to get rid of tangent is you inverse tan it. Whatever you do to one side, you do to the other. So I'm going to note, make sure you find out what 42.5 divided by negative 200.5 is first. And then you're just going to inverse tan that answer. So tan and inverse tan get rid of each other, leaving you with theta equals, and this would give you negative 67.43 degrees. So that's your direction angle. I kind of want to throw this out there. You might not see it in the example, but just a fun fact, negative angles means they go clockwise. They're going this way. So to get to this vector, the only way I'm going negative 67.43 degrees and hitting this vector is if I'm starting here. So this is actually the direction angle. Since most direction angles should be seen as positive, if I were to find the angle from here to here, knowing that this is negative 67.43 degrees, notice that the two of them add up to be 180. So to find out what the positive direction angle would be, I would just add 180 degrees to 67.43. Not that you'll really see it, but just a fun fact. You shouldn't really see anything like that in the example, but graphing the resultant vector, knowing what vector or knowing what quadrant you're in will help you with the direction angle as well. Make sure you brush up on the unit circle. If you haven't already done so, you will see it a bit in this module as well. All right, guys, hope this helps.